Hello Form 4 students. So today I would like to bring to you the chapter 8.3, the exponential equations and logarithmic equations. So you have to get the idea that in this session, okay, you will have to learn these two kinds of equations. But the most important thing is that when we talk about the exponential equations or logarithmic equations, we have to involve of the variable with index. That means that what? That means that you may have to do the equation with some variable. For example, when we say the x as the power, and then on the other hand, you may have another thing with x. For example, we say s something. For example, I say 4 something like this. So this is the kind of exponential function. That means that you have to expect that the variable, for example, x, would becomes part of the index. And how about the next one, the logarithmic equation? The logarithmic equation actually means that you have to prepare that the equation should have something like log something, for example, log a something, and then equals to something. That means that actually we have to use the things we learned in chapter 7 and chapter 8, which is the exponential and logarithmic, to solve for finding the variables using in the equation here. And now let's take a look to see the first part of exponential equations. So you can see that there is a yellow box here, but I think this yellow box is not very important because actually you have to understand the most important thing is that exponential equation is not a new thing to you, because you learned exponential equations actually in Form 2 and also in Form 3. And also you can take a look at example 9, a very easy example. You can see that now when we talk about the a, 5 to the power x plus 1 and equals to 5 to the power 3 minus 2x. So what we need to do is that now we can see that the two parts, the right hand side, the left hand side, have the same base 5. It means that actually after you know that they have the same base, you can just extract their powers to compare. It means that if in the equation there are only two terms on each of the base, for example one on the left and one on the right with the same base, so actually you can just compare the index. After you have compared the indexes, then you can get the x. So this is the simplest model of exponential equations. The b is also, even you can see that the right side is square root 27. So once again you apply the law again to change square root 27 as the power of 3. For example, this one you have 3 to the power 3 over 2. So once again, you just compare the indexes and then to get the x. That means that for the basic idea of exponential equation, the most important thing is that we have to compare. We have to compare what? We have to compare the indexes if they have the same basis. Now, we take a look to see another kind of example. For example, we take a look on example 10, this one. So this time you can see on the left hand side, there would be two base 5 thing added together. But do remember is that if the terms are added or subtracted to each other with more than one term, for example here you have two terms on the left, so you cannot just only compare, because we can only compare when they are in the equation left and right. That means that they should be placed in different places, okay, on the equation. But now you can see that these two base 5 things is both on the left hand side, so we cannot just compare. So what we need to do is that now we have to take out the common factor in order to make them together, because you have to understand is that if there are two terms adding together or subtracting to each other, we cannot apply the law of index. The law of index involving multiplication of two terms with the same base or different base or something like that, but we cannot doing the addition and subtraction. So what you can do is that to take out the common factor. And what is the meaning of taking out common factor? We take a look. Now, you can see that 5 to the power x, it seems that it is the simplest term. You cannot do anything. But you can see this one, 5 to the power x plus 1. So this one is, you can see the x plus 1 here. That means that you can do something. And the thing we have to do is that we have to change it in this way. So why we have got this one? Because this one actually just means that you write 5 to the power x times 5, and then you have this one is 5 to the power 1. And why we have got this one? Because this one is just apply the law of index, that if they are multiplied together, you can add the index. That means that the index, if they are added together, so you can make it separate here as 5 to the power x and 5 to the power 1. Then this 5 to the power 1 actually means the multiple 5. And also you have to understand that if I say 5 to the power x, actually it is means 5 to the power x and then times 1. That means that now you can see that besides the term 5 to the power x, the 1 and 5 to the power 1 are called the multiple. That means that they are just the multiple when they are involving taking out common factors. So when you take it out, then you have this one. And this one will become another multiple. For example, you can get 6. So this number 6, not involving any power of x, can be divided to the right with also numbers on the right. So you can see it. Finally, you will get a very simple thing. 5 to the power x equals to 5. Then you can get x equals to 1. Now, so this is the kind of questions that we have to involve of taking out the common factor. And the common factor actually is something power x or something of the base power x or something. But the most important thing is that we have to see what numbers are the multiples. And the numbers are, which are called the multiples, are simply the term without any power of x or any power of variable. So they are the multiples. Then you can simplify them by adding or subtracting together, and then to make this number divided to the other side in order to make the question more simple. Now, so please remind this kind of example, because from my past experience, I could see many students felt very difficult when they did this kind of question. And after that, then we continue to take a look. So sometimes you can see the numbers, okay, on the left and the right are not in the same base. For example, you can see 6 to the power x equals to 12. Do remember, even 12 is a multiple of 6, but it doesn't mean that it can have the base 6 easily, okay? Because you have to understand that if I say 12, this number, okay, I can say this one is 2 times 6, but it doesn't mean that it is equal to 6 to the power 2. But it is 6 to the power 1, actually it should be an irrational number, because 6 to the power 1 is 6, and then 6 to the power 2 is already 36. It's over 12. So you have to understand is that even 12 and 6 has a certain relation, but it's not in the exponential relation. So please be careful. But anyway, for doing this kind of question, actually, you can see that the book will show you taking LG. And this one is a common log. That means that we are taking LG 10 on both sides. So why do we have to do so? Because once you have applied the log on both sides, you can take the index from 6 to the power x out as a multiple with log 6 here. That means that the powerful 2 LG log is to help you to take out the index from your term, to take it out as a multiple. Then after you become the multiple, then you can just simply using division to do the other things. For example, x times log 6, so you can divide the log 6 to the right to make it become the quotient like this. But this quotient actually you can see is log 12 and log 6. You cannot know each of them directly because they are irrational number, but you can use calculator to help you find the final answer. So that's why the question will ask you to express your answer in three significance, because the question already giving you the hints that actually your answer may be irrational, because we ask you to write the answer correct to three significance. So you have to use calculator to help you, or otherwise you cannot calculate it. But the most important thing is that for this question you can also apply the definition, because if I say 6 to the power x is 12, you can simply to write x directly by writing this way, log small 6 and then 12, because this is the definition of log. Okay, so you may ask also that, oh, Mr. Wong, why the book teaches us that we have to use a very complicated method by taking log on both sides instead of using definition? The reason is because in the older version of calculator, it cannot calculate, okay, the log small 6 and then 12, but it can only calculate the LG, that means the common log, and also the ln, the natural logarithm. So if the calculator cannot help you calculate log small 6, so we have to take the common log on both sides and then to simplify. But actually from now on, okay, the newest model of the calculator, just like the Classwork FX50, FX2, it can help you to find this one directly. If you still remember that in the last clip, we say this one you can use a calculator by simply pressing this one, log and then bracket and then 6 comma and then 12. So do remember is that because the calculator can help you find this one already, so you can actually show the step only this one. and then to give me the answer in DSC. Okay, so it's no problem. And now we take a look to the other harder example. For example, now you can see the example 12, this one. So if the terms would be a little bit complicated, just like you can see the 12a and 12b. So we take a look at the 12a first. So for 12a, you can see that now you have two terms also. But this time you can see the second term, the index is a little bit complicated because you have x plus 1. But no matter what, you can just apply what the book wants to tell you is that you take common log, LG, 10, LG on both sides and then to simplify. But the most important thing is that now when you take the LG, you have to be careful that the index you have taken out from the right, it should be x plus 1. But because x plus 1 is the whole index originally, that means that after you have taken out, remember to put bracket. And then after that, you separate the bracket by multiply the x to log 4 and also 1 to log 4. So this is a very, very important thing because it is also the common mistake I always see when I check student homework or student test paper. So please be careful is that there should be bracket. And what you need to do is that now you will have three terms after its expansion with x log 3, x log 4, and log 4. Do remember x log 3 or x log 4 just like a multiple x with another number multiple with fourth log. For example, x and a number log 3. So after that, then you put all the terms with x together. Because we want to find x, so we have to put x as subject. So when we put x as subject, so the step we need to do is to writing all the subject terms to the left hand side. Then we put it on the side and then you take out the x. Then the things you have taken out would be something like log 3 minus log 4, but you don't need to care because all the things here without x, so you can just simply divide the whole things to the right afterwards. Then you will get the number also. So you can see that besides of taking log, as I said, you can also take any log between it. So you can see that in part A here, you have two terms, which is one is the base 3, one is the base 4. So also I can also take the base 4 directly. Then you can see on the right side, I can simply cancel the 4 because you have taken the log 4, the log base 4. So the 4 will be cancelled, just only have x plus 1. Then you can see that we can also apply with the same way by seeing on the left here because the base is 4, but the original term is 3, so you cannot just simply cancel it, but you can take out the power x out to make x bracket log 4 of 3 equals to x plus 1. So once again, you subtract the x, and then do remember is that after you subtract the x, you should have the common factor 1. You have to have the factor 1 because x should be x times 1, so you have to put the 1 inside the bracket. And once again, you can make this number to the right. You can still get the things something like 1 over log 4 3 minus 1. These two answers actually are the same. But why they're the same? So I just leave the proof for you to try. Okay, so you can also do it in this way. Now we take a look on the last one. The last one, this one is a little bit complicated because you can see this time the left hand side you have the term 7 also. But no matter there is a term without power x, for example, you have only multiple 7 here. So just remember is that you can also take log both sides. But do be careful the rule that you have to use to simplify. For example, you can see this one is something like log something. For example, I say the 7 is m and then times n. So do remember the rule is that it should be log the first term and the second term log. So this is the recall from what you learned in the last clip because this is the property here. So please remember is that here we are actually using this way. So no matter how many terms you have, so just remember to follow the rule clearly and use correct operation symbol. For example, here, two terms multiplied together after you expand the log, it should be plus. And then now you can see all the terms will become plus and minus 1 by 1. So once again, you apply what I said is that you group all the terms with x, you put all the terms without x to the right, and then for the left, you have all the terms with x, you take out the x, and then you have the factor which is not x, then you just divide. So you can see B is also doing this way. All important thing is that why is we call this one difficult? Because many symbols here, many operators here. For example, addition, subtraction. So you should do carefully. And also when you press your final answer using calculator, do remember to key in also bracket if necessary. Okay, because I could also see that some of you could get the last step, but they cannot use calculator well, sometimes forget to put bracket in calculation. So please remember, key in bracket, okay, if necessary. So this is what I want to bring to you about exponential equation. So now, take a look to see if there are any problem. So if no problem, then the second types of the equations that you need to do would be the logarithmic equation. But you can see the book will also show you some application problems. But this one, let me tell you later. Now we bring to the second one, which is the logarithmic equations. For logarithmic equation, it would be a little bit difficult because this one we have to always keep in mind a very important idea is that no matter which kind of log equations, that means that the equation of log, always check the answer. So for exponential equation, I did not tell you that you have to check the answer. But for logarithmic equations, I always say you have to always check the answer. But why? So I would like to bring you now. Now, for logarithmic equation, the idea is very similar to exponential equation. It's just like that we have to compare. We have to compare the left hand side and right hand side in order to see what is the x. So you can take a look to a. For example, this one. 2 log 4x minus 3 equals 0. Now, so you can see here, you have two terms on the left hand side. One is 2 log 4x, subtract 3. So as I said, plus and minus is not very important. It's not a good thing because they cannot use it for combining the terms in using exponential log. So what you can see that we have to do is that we add the 3 to the right and over 2. So you can see now you have one log on the left and one number on the right. So the term will become 1 on the left, 1 on the right. It will become easier and clear. And what you need to do is that now for log 4x equals to 3 over 2. So do remember the definition. For example, here you can see it now we have to write this one. And this one actually is by definition. That means that it is the meaning of log. That means that once you can see log small for x equals 3 over 2, so how can you cancel the log 4? It's just like that you put the base back with 3 over 2. Because 3 over 2 here is your power. That means that you can just write x and put the base first, and then the 3 over 2 will become the power. So you can just see like in the example. And then what you need to do once again, because you can see on the right side all the things are the number. So use your calculator. Then you can get x. But please remember is that even this very easy question, always keep in your mind that after you have got the number x, put it back to the original equation to see if there is any problem. What is meaning by to put it back to see if there's any problem? That means that you key in 8 with 2 log 4, 8 minus 3 to see whether there is a problem shown in your calculator. So why do I say it? So you can see in the other example. Anyway, so we focus on this example. You can see it now. We can do in this way, it's very easy. So even for the part B also. Now, even you can see this time two terms. One term on the left, one term on the right. Both with the base log 5 here. The most important thing is that now, if you have two terms with the same log 5, you can just cancel. That means that now, for 2 log 5, 2, you put back the multiple 2 as the power. Then you can see it now, the two terms both on the left and right will have the same log 5. Then you can just simply like to cancel them. Even if they are not numbers, but it's just like they have the same operation, so we can just cancel it. Just like if I say square root x equals to square root y, and if you know x and y are positive number, then I can also simply cancel the operator to become x equals to y. Even square root is not a number. So here also, if I say log 5 and log 5, they are just only operator. Because of some property, they can just cancel to make the terms are equal. So you have x plus 1 equals 2 power 2, which is 4, so you have x is 3. So this example, I think that you can easily get the answer, even you try to do exercise in the book. And now, we take on the 15. So for the 15 also for this one, okay, you can see this time you have two terms on the left, but they have different log. So you cannot do anything with different log. So what we need to do is that we have to change it as the same log. But this problem, I think that is a little bit difficult to you because for this guy example, you can see it. This guy example, you can see it. Now, what term you have to change is that we always change the term with the greater greater base. But actually, you can also change the first one. But the most important thing, how do we change it, is that now you can see because this one is log 4, which is not easy to calculate. So what we need to do is that we have to use the change of base formula to make it become the same base, like the first term 2. So this one, remember that it is the change of base formula, which we learned in the first clip. And after we've changed the base, you can see it, the denominator log 4 will become a number, and this number should be treated as a multiple. For example, now you have the 2 here, so we will say this one, log 2x over 2 is 1 over 2 multiplied with log 2x. And this one, once again, is 1 times log 2x. So always keep in mind the idea is that the number multiple with something, with exponential or log. So these two things, for example, 1 times this one and 1 over 2 times this one, then they can be added together, becomes 3 over 2. So this is also the idea in logarithmic equation. This one not easy, but try to accommodate and try to practice more. Then you can see now it will becomes a very simple equation as log 2x equals to 4. So you apply the definition again to get 16. So the last one is what I want to say before, is that why do we have to check the answer? So now you can take a look on the part B. The part B, now you can see the equation is something like this. Log bracket 3x minus 1 equals to 1 plus log x plus 2. So you can see this time the right hand side of the number 1. And you can see the addition side, the plus here. As I said, it's not easy to simplify the plus. So you have to try to use some skill to make 1 and log bracket x plus 2 together, that you can calculate furthermore. So in order to do this one, what we need to do is that now, because you can see it in this equation, there are 3 terms. 1 does not have log. So what we need to do is that we have to change it becomes log something. But do remember is that when we say 1, when we change to log, it's just like that we have to ask log with what base. For example, when we say the base is 2, then we write to the power 1. If I change another base, for example, I say change the base of 3, then you can get the idea is that this one should be 3 to the power 1. Why do we have this one? Because this is definition, and also this is also one of the property we set in the first clip. So if this time all the log you are using is LG, common log, that means that this time the log is just only 10. So we have to have this one become 10 to the power 1. So why we say this one is equals to log 10? It is because it's just like log small 10 to the power 1 is 1. Because we just change log if the base is 10, so 10 to the power 1 is 10. So like this. Then you can easily see that now after this, then we have to apply the root to make it together, because log plus log we can becomes multiplication. So once again you can see log 3x minus 1 and log multiple of 10 and x plus 2 together. You can cancel the log to make the equation like this. Then you will finally to get x equals to -3. But you can see this time there will be a very important thing is that we have to reject the answer. But why do we have to reject the answer this time? Do remember is that you can see now the x is a negative number. But do remember, not only negative number you need to reject. Sometimes you may have to reject x is positive number, or x is 0, or nx. Because the most important thing is that after you have got the x, for example here is -3, you have to put it back to the log equation to see whether there's a problem. What is the problem? When we put x is -3 into 3x minus 1, you can see at this time, you will see that 3x minus 1 will becomes -10, because x we have -3. But do remember is that we cannot have log -10. Because log -10 just asking you that -10 is 10 to the power 1. I did not mention this one in the first clip, but you should understand is that because when we think about the exponential function or log function, we are actually dealing with positive number, with positive basis. So the positive basis with any power, even this negative power, cannot become a negative number finally. That means that if the log with negative number, it is not defined. That means that we can not say log -10 is anything. Log -10 actually is nothing. So we have to reject it, because -3 put to the log would make the things undefined. or simply when you put it in the calculator, we will show you the math error. Okay, the math error. Sorry. So you can also see that if you use calculator to check, you have something like math error. It means that the calculator will show you the error message is that because this one is not defined, so you cannot show any value. So do remember is that no matter what, you have to put it back to see whether your result becomes not a negative number. If not negative number occurs, it means that it is not allowed. That means that the answer is not acceptable, so you have to reject. So if you have no answer kept into your question, so we will say the equation has no real solution because all the answer should be rejected. Okay, so this one is a little bit special, but try to understand is that for log equations, always put the number back to see whether you have log negative number. If it is, it means that this answer is not allowed, so you have to reject. Okay. So this should be the last example in this session, and also you can see the application problem. But application problem, I think that I have to put it into the next session, okay, to talk together. Okay, but I think that actually the application problem are easy, so you can just read by yourself. But anyway, so this is the end of the chapter 8.3. So do remember is that for this session, I strongly suggest you doing this 3+1 question. Question 15, question 29, question 30, and also question 31. But question 31 is an optional question. Optional question, so you may try to do opposite question 31 in your classwork. So just like once again, okay, I set the due date of the classwork will be the 25th of February. So I changed the due date also, okay, of the last class will be 25th of February. So why did I change the due date? Because on the 26th of February, so there will be an online lesson for Form 4 in Maths. So I will take that online lesson. Maybe I check the questions and teach you how to do those classwork, okay, during the online lesson, or maybe I will continue to teach you the last session of the Ch8. By the way, so just wait and see. Okay, so this is the end of today's clip. Goodbye.